For the non-wedged case, we have this capillary beam expander, so the beam is perfectly collimated. This means that we're getting a plane wave coming in, and it reflects and refracts, creating two different plane waves that interfere and create this null fringe here. When we defocus this lens, either left or right, the beam either diverges or converges, so we get this circular wave coming in. And this creates two virtual point sources separated by shear distance s, and they interfere and make these fringes here, which are parallel with y sub b. For a wedge shear plate interferometer, we have this wedge angle of beta. So for the first case, when the beam is collimated, we have the exact same plane wave coming in. Now, the interference pattern looks like this, and we have the interference fringes parallel to the x sub p axis. For the defocused case, we have the exact same circular beam coming in. Now, this creates two virtual point sources separated in y by 2n beta, which is the wedge angle, and in x by s over r. The interference pattern looks like this. So here we can see that the fringes are tilted such that alpha is our shear angle and s our separation distance.
Here are a couple different interferograms. The top two represent zero wedge shear plates. Now for the top one, we have good shape factor. And for best focus, we'll get a null fringe. As we move outward, both positive and negative defocus, we'll get vertical fringes, always vertical. Now as we move further out of defocus in both directions, you'll get more fringes. As we induce a bad shape factor, we'll get spherical aberration. Here's the best focus case, and depending on which way out of focus you go, you'll get either this orientation or this for the spherical aberration.
As I adjust the decenter of the lens slightly, you can see that the fringes change. Contrast, so you get white, then black, then white, then black, and they also translate. Now if I change the defocus slowly, then you can see the different shapes. This is going positive defocus, and then negative defocus, you start to get this shape.
Now, with a wedge shear plate and a good shape factor, we'll get horizontal fringes. Actually, in both cases, we'll get horizontal fringes when we have a best focus. But with spherical aberration, we'll get this S shape. Now, as we move out, we'll get a counterclockwise orientation to these fringes. And here, we'll again have the S shape, but see in the center, we still have that counterclockwise tilt. And with the case of negative defocus, we'll get clockwise.
When we're collimated, we'll have a zero order with our non-wedged shear plate. But with our wedge shear plate, we'll just have fringes that are parallel with this line here. So as we translate the stage in and out of focus, we can see that our lines move off from this horizontal line. And with our zero wedge, we see that we have a zero, our null fringe, and then as we move it out, we'll gain fringes.
With a shape factor of -1 with decenter and defocus, we got this interferogram. Once analyzed, we got these results. You can see the amount of defocus and the amount of coma. With this one, which just has defocus, you can see that the coma is smaller than in the previous, but we still have the same amount of defocus, which we want. Where it's collimated without defocus or decenter, but with a shape factor of 1, we do get a lot more spherical aberration, which is anticipated. We get a little bit of coma, and we did actually get a little bit of We have just decenter, but with a shape factor of 1. Same thing, there's saturation. You can see that it's still pretty close, though, to what we expect. We still get that large amount of spherical. Now, since there's decenter, we're getting a good amount of coma. Our defocus increased a little bit, and then with just defocus, but no decenter, because of the saturation on the camera, it was much harder to determine where to take measurements, which led to a polynomial fit that didn't work as we expected it to, and instead gave us this right here. Tilted, as in this picture, the interference fringes stay pretty much the same as when not tilted, but they're just shifted. This is also true seen here for the Y tilt case. Now if we do tilt and defocus, you can see that we start to get angled fringes that are angled from this line here, and they become more frequent. Which is expected. We right now do not have any quantified results because our algorithm is currently having trouble processing these curved shapes within our interferograms. At the best focus with the vertex of the mirror and the focal point coincident, we get this shape with this flat part of this S shape parallel to this line. This means that we have no decenter, all we have is spherical for the most part. When we do have decenter, you can see that this shape here has shifted, and going back and comparing, you can see that it's slightly different.